So I think we have stopped in the tool lighting. So inverter layout. So I'll just revise again. So anybody having tool doubt? One second, I'll just log in my tool access.
Hi. Suresh. This is Suresh from Takshila.
Yes,
Hello.
you can.
Just 2 minutes. Hi. Good morning for everybody. So this is Suresh from Takshila VLSI. So some of the few candidates are there for new joiners. Don't worry about that and all. So we'll give you the whatever the topics is covered. No, maybe next week or previous week. So we'll cover the whatever it is completed topics and all. We'll extra timing. We'll spend the time and we'll give you that. Because one more batch is going to be completing from your senior batch, like 16. So once it is completed, we'll take the extra class and we'll cover that. Okay. So
Yeah, sure.
Okay, sir. Thank you, sir.
Thank you.
And materials also will courier after 15th. So actually in a month, we'll be dispatching for the 2 times, after 15th and 30th every month. So whoever the new joiners, don't worry, we'll send you to the according to your pipelines.
Sure.
Okay. Any other doubts?
No, sir.
Okay, fine. So any doubts is that yes, I'll be there in the group. Just ping to the personally. I'll give you your solutions. So this is the major query. Everybody is asking for that. So pending classes. Don't worry about that. I'll give you that definitely, and as well as placements also.
Okay, sir.
Okay, fine. Fine, Suresh. You can continue.
Thank you, Suresh. So those who new joining, username password you can collect from our institute. Means our admin will be take care, and they are already told Suresh, so you will arrange the backup classes. So before that, I will give you some basic idea. So what is our layout people we are doing? So this is the CMOS inverter we are going to design. This is just a basic schematic of a CMOS inverter. So it's having CMOS having, this is a PMOS that I will color it. This is the PMOS. If this bubble is there, this is PMOS and this NMOS. This is in, this is out. Okay, so here having 4 terminals. So 4 terminal means one is gate, source, drain, body. So B for body, D for drain, source, gate. So having 4 terminals. So another terminal same source, drain, source, body, gate. Okay, so this is called your altogether. So PMOS and MOS, if it is combining, it is called CMOS. CMOS is complementary metal oxide semiconductor. So why it is complement? If you sending input 0, in output you will get 1. You are sending 1, output you will get 0. So I just tell, if you sending 0 means your PMOS will be turned. NMOS will be open circuit. The NMOS on means this is like, so those I have repeated. No need to worry, just I am giving the clarity. Let assume this is type of switch. So this is also a switch type of thing. It is connected to here. One is VDD, second one is VSS. So your PMOS will be on, so switch will be closed. So now Vout equal to VDD. For digital, there is a 2 term. One is 0 or 1, binary. So VDD is like a high input, so it will be taken as a 1. Okay. If it is 1, your NMOS will be turned on. So in higher voltage, NMOS will be turned on. So if it is NMOS turned on, so this PMOS will be open circuit and this one will be short circuit. So Vout equal to 0. Okay, so 1 sending 0, 0 sending 1. So this is like a complement. So that's why it is called CMOS, complementary metal oxide semiconductor. MOS, it is like a metal oxide semiconductor. If you go to inside structure, these are called NMOS, PMOS. N for N channel, P for P channel. Okay, so this is the basic thing we are going to design. Its layout will be, and its this is a schematic view. Okay, if you go to more detail, there is a second term is called I'll give you just a brief idea. Next term is called I have recorded. So fabrication is the very good one topic. So fabrication is a study how this is CMOS is creating. Means in the company how they are making. So this is the process. So how will we learn? So this is your CMOS. So one is PMOS. This is called your cross-sectional view. So if you cut one pieces, inside what you will find, that is a cross-sectional view. Okay. So cross-section means internal how they are present. So this is by default, this is P substrate. So why? Because P substrate always take as a reference. Its mobility is very less, so it will not react with anybody. Annual will be okay. That concept will be done later. So first to understand P substrate by default this one. Second, NOL they will create it. Inside NOL, P plus. So P plus just a doping concentration is high. Doping concentration means, see, if you semiconductor, its current will be not that much high. To increase its conductivity. Conductivity means increase the current carrier capacity. So to increase that, the doping concentration, this is the P plus. So it is present inside NOL. This is P channel. So this is P channel means this is PMOS. N channel means NMOS. Okay. Now next body. Body is like a same as your substrate. So NOL substrate means N plus. P substrate means P plus. So don't confuse in the NMOS which cap. So this is, if you understand, this is the CMOS inside. In NMOS which cap your, this is P plus, or we can tapping of a body. That is called P tap or N tap. N tap is the across where P inside the PMOS only. To connect the PMOS, you need a N tap. I just repeat this point. So this is your PMOS. You need to connect body. How will be connected? This is here called N tap. This is your NMOS. To connect that body, you need a P tap. So don't confuse. Some people are asking NMOS across N tap you will place or P tap. This is the clear. Or anybody having doubt. And somebody asked why you cannot body directly metal. So this is a metal. How can you connect a metal and semiconductor? It should be doping percentage should be high. Directly you cannot connect a conductor to a P substrate. So P substrate is the lightly doped. Okay. Is it audible to everyone?
Yes, sir.
Okay, so now you understand how it is going. Initially, they will create P substrate. So this is the P substrate. Then over P substrate, they are adding Si2 layer. Only say this is called dielectric layer. So before that, today I'm just telling this is the fabrication step. So I didn't go that much depth. So if you see in the atmosphere, it is called sand. Sand is available. From the sand, it is vapor is creating. What is vapor? This is called pure form of the silicon. This silicon, if you see, so everything where this is the metal silicon are using. This P substrate, P type of semiconductor, N type of semiconductor are using silicon. So how this creating? So there is a process called Joukowski. So in this process, initially they will react with silicon dioxide with carbon. So if they react with high temperature, so it will be silicon liquid will become. So this will be liquid and carbon monoxide. And this is liquid is not a pure form. Again, they will in this MgS hydrochloric they will add, and they will form silicon hydride. So these are not required. Just for I'm giving idea. So I'll show you the. Means we have to know some what is how it is forming. Cellular and trisilane, one of the liquid also form. It is also a not pure. Joukowski method means you just see means for creating the silicon. So how this silicon it is forming? If you see, they are heating. So this process liquid silicon they are finding. This polysilicon in the okay. So now in the this is like a this in the glass they are putting some water. What it is you are able to see some water, but this is a liquid form and it is in high temperature. So it is in liquid form. If you take some lower temperature, this is like a high temperature here. This is lower temperature. What will happen? This liquid will become solid, and this solid they will be cut. This form is called your ingot. And they will cut into one pieces. Ingot will be formed by using diamond saw. They will be slices into thin wafer. single crystalline income. Okay, so they will chop, and there is a process. After slicing, they will be lapping, etching, polishing. So etching means some metal will be there, they will remove it, they will do polishing. After polishing, they will create this type of wafer. Over this wafer, they will add silicon. So this is like a p substrate. Then if you they will combine with the p type of semiconductor. The p type of semiconductor means some people will not understand. So before that, I will show you the diagram. And here today we will take little bit more class up to 1-2 hours. That's why I am showing little bit. So what is this insulator, semiconductor, conductor? Band depends on the band gap. Energy gap difference between. So if you see this group 3 element, this is the periodic table. So this is silicon is present, group 4. So if you adding p type of semi like boron, aluminum, it will become p type of semiconductor. If you are adding group 5 element, it will be n type of semiconductor. So generally this boron will be used, arsenic or strontium. So these two metal will be for group 5. And we are available group for silicon and germanium. So maximum silicon will be used. Okay. So if they are adding boron, it will be p type of semiconductor. So just now I saw the diagram. In fabrication, the p type of semiconductor means this is p type of semiconductor. So where they are adding, after silicon only they are adding. So this is the p substrate silicon. So how this pure form the silicon will be formed. So I'll just show you one video.
Companies know too much about you. Mine will help you stop it.
Kate? Kate Williams? It's me.
So they first taken from sand. Now this is called ingot. Okay, they are hitting you with sand with high temperature. By using diamond saw, they are chopped. Okay, this is the pure form of the silicon. And these are called 3D print. Imprinting means 3D print how they are do some layer. So they are adding like p type of semiconductor. How they will add in this process they will add. So this is called photolithography process. So when you tell the discuss fabrication, you will get more clarity about this point. Okay, so now you got idea. So this much I am telling. This is the silicon how they are formed after ingot. They are slicing into this is the pure form of the silicon. Over the silicon, they will add the doping concentration. If they are adding boron, it is become p type of semiconductor. So this is the P substrate. So P substrate is P type of substrate they are telling, because inside that everything will be found. So if you see your layout, anybody can tell the number. BNC number.
20.
So in the layout, you are able to see this is the black screen. So this black screen is a P substrate. Okay. This is by default all are P substrate. So you no need to draw a extra layer. So layout will be identify this is a black screen are called P substrate. This is like a over that everything you will be do. So like that, this is the P substrate. Over that we have to do NMOS, PMOS. Okay. Any doubt till now? Next come to. So we need to inverter. This is a cross-sectional view of a NMOS or PMOS. So PMOS means your P channel. So you which layer should be present. So that is also you need to know. So let's take an example. This is a PMOS. And yeah, for those who joined in recently, so we will be cover this topic. So you are able to see this is your NMOS. PMOS. So PMOS means P channel. So by using gate, your gate is like a controlling. So P channel, this is like a tap. If you see your water tap, so water tap is a controlling. So gate is a controlling your channel. By using, suppose you will create a positive voltage, your negative will be created here. If you apply negative voltage, the positive will be created. So channel will be created. So this is P plus, this is a positive channel. I will tell you that no need to worry. So anyhow, negative voltage means that's a gate will be taken negative voltage. So negative in the digital is taken as a 0. So if you see PMOS, it will be turned at negative potential. Okay, I'm just giving clear view. So before starting showing the layout, you should have some idea. Now this is the 0, so that's a gate terminal, and this gate is isolated. Isolated means this is a two types of, one is depletion mode and is enhancement type. So MOSFET is a, already you know, this is a metal oxide semiconductor. So it is having 4 terminal, unipolar. This is not a bipolar like BJT is a bipolar. It is a unipolar. It is a voltage control device. Okay, so this. So if you see how it is classification, the MOSFET is JFET junction type, one is MOSFET. FET is divided into two types: junction FET field effect transistor, another is MOSFET. And this MOSFET is again divided into depletion type and another is enhancement type. But we are going to deal with enhancement type. Enhancement type means no channel will be present before. Depletion type means so there will be no CMOS. Your VLSI industry, you are not going to use depletion type because it is not a gate is not controlled. So somebody will be controlled, that is more effective. Sometimes channel already there, so you are investing huge of money. But enhancement type, it will be whenever device required at the time will be turn off, you are controlled. So that time, so maximum 100% device is called enhancement type 1. So this enhancement type we are going to study. This is the channel region. So you have to deal with channel and width. It's having some devices having length and some oil. Okay, now come to our design. So if you see, this is the cross-sectional view of a MOSFET. Like this is a PMOS. So its layout view, how it be looks like. So layout view, if you see,
Sir,
Yeah.
I have a question on the PMOS and NMOS. Can you go back to the PMOS and NMOS that layout design? Just now you're showing me the drawing, right? Yeah, this one. Okay, I wanted to ask, for we have a source and drain, right? So, and that gate we giving power, so it will be on. So when the no matter doesn't matter that there is NMOS or PMOS, when the NMOS and PMOS short circuit, actually the current flow from drain to source or source to drain. Can you understand my question?
Yeah, so irrespective of your terminal, you are telling current will be flow from. So let us assume this is a NMOS, okay,
Okay.
and let
So
us
we
assume
have
this is a PMOS. Okay, so current,
okay.
you see, I'll take an example.
Okay.
You only tell. So this is your 5 volt. This is a 1 volt. Second case, the first case, current will be flow from this direction or this direction.
From 5 volt,
5 to 1. Yeah.
5
So
to 1,
how can you tell? This is higher
because
potential, this is a lower
low
potential.
potential. Yeah.
Okay. So it depends upon the terminal which potential is connected.
Okay.
This is the assumption. Now come to our point. So generally when you connect,
Mm.
this is a drain, this is a source.
Okay.
So this drain for NMOS, it will be connected to higher potential. Let's take an example. So if you see, this source is connected to VDD. So this is the higher potential. So current will be flow from PMOS to source to drain.
Yeah.
From NMOS, current will be from drain to source. Why? Because this V out is potential higher than, it is related, assume some potential, it will be 0 volt. So
Okay.
this is the way, the assumption.
Okay.
Understood?
Yeah, understood.
Sir, actually, I was not able to get to this screen actually because I am not able to apply those codes, line of codes.
Sorry.
Sir, I was not able to apply those line of. Okay.
So this command, can
Sir,
you tell the number? BNC, your number.
yeah, 62.
So for your lab number is,
Okay.
so once the 62 for your lab number is 65. So when you start, okay. But when you are using Linux command, after CD you have to give in the space.
Okay.
Okay, somewhere your file name is missing. So it will be, I'll tell you back to back. You can take a screenshot. This is for your number 65.
Okay. Okay. Just a moment. Yeah. Okay.
Yeah, I can continue.
Yeah. Thank you, sir.
Okay, so up to what I told, I forgot. Inverter tap, I think I told till now. Okay, anyhow, I'll repeat this again. So I'm just fit it. So this is the schematic of the inverter. So how you know already. So I will take from PMOS. You have to go to browse. This is the project you are doing, GPDK 90. So this is PMOS one board you have to select. Then create symbol, close. You can change. So our width and the length, width we are taking for PMOS. So here 100 nanometer it is fixed only length. Width here to taken for PMOS. $360 nanometer for NMOS. $240 nanometer we are just taking. So this is our designing. So if you see like that you can take, and here NMOS you can take, you can for connecting. Just I'm doing little bit first. This is how you can connect. By pressing W equal to air, you can connect. For adding pin, you can press P for add pin. P if you press, it will become add pin. You can type the pin name like VDD. This is how it will become. Then you can connect to air. So this is the schematic designing process. So I'll just undo. Yeah, so anybody having doubt in this schematic designing, let me know. So anybody having doubt in the schematic design for inverter? Next step.
Yes, how to take that VDD symbol?
Yeah, so if you see there is a,
Great.
you can select pin. Okay,
Yeah.
if you see there is a bind key. Bind key means you keyboard directly press P. This window will become. Okay, so you can type your pin name like VDD. It will become like this.
Okay, so after I type the pin names, right? So after I type the VDD, so I should click which one?
Mouse left click. If you see, it will be stop there. So like let's assume I'll delete. I'll show you again. See how I'm creating. Create pin.
Mm.
You can type VDD. That's only. Then go to hide.
Oh, okay.
If you hide, it will become this window. Then you can mouse middle click. If you see, you can rotate also. This is how. Mouse middle click only. You have to click. Or you can scroll bottom. You can. We are just going. Yeah, this is a left click. This is a right click.
Mm.
This is a scroll button. If you click scroll button, it will be rotate.
Okay. So how to pull that wire?
Now where you can press W. So everything, the bind key is like a first letter. Suppose where you are drawing now, so it is be like this. See, this is a W. So where you need to stop, mouse left click. You can click this mouse left click. It will be stop there. Where you need to stop. You got? Do you have access?
Yeah.
Username, password.
Yeah. Got.
What's your number?
44.
I think they didn't give to me. You can send me the password.
How I can send the password?
Yeah.
Can I send you on WhatsApp or what?
Yeah. You can send me in WhatsApp.
Hold on.
Sir, actually, I created all the schematics and the layout for the inverter, but I am not able to see all those currently. I don't know where it is. Yeah, for 62. Yeah.
So I already PM you. Please check. You said your number is 9199912340029.
No. I shared the link for meeting ID. I shared, so that number only. 799. Yeah, Sumit, your name is not there.
Yeah.
Okay, so your this is number should be 65 correct only now. 62 Sumit Das. Okay. Sumit, I think you have created some different path previously.
Okay.
What you did previously, you have launched the tool in the different folder.
Okay. Okay.
So this is the actual path. Okay, so you have might have created in the desktop.
Okay.
Let me see.
Hmm.
No, here also you didn't create. See, here it is clearly written 65 only.
Yeah.
MS lab.
Yeah.
So I have the direct message my password on Zoom meeting.
Yeah, I got here. I'll check.
Okay.
I think Sumit, you have to create starting only. Somewhere you have created. This I cannot because this number will
Okay.
different. Yeah, maybe somebody other people can tell you.
Okay. Take.
So you have to next time onwards only AMS lab. So that path already I told you.
Mm-hmm. Okay.
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 Okay. You can type and launch.
Take.
And you have only inverter we did only, so no need to. It will take very less time.
Yeah. Yeah. Yeah, Saban Raj, your name is okay. You can tell. Yeah, what is the issue? Where you need to draw. So
Okay, I just want to pull a wire. So how to pull the wire?
so this is you have to press W. I'll do
Okay.
onto it. Press W. Click the
Press
mouse
W.
left click where to where you need to do. Not click. You have to click the where. Suppose you need to click here. Yeah, there only click. Yeah, mouse left click. You have to click mouse. You didn't click. You have to click one time. Yeah, understand? Yeah, correct. Yeah, you have to click only. Then go to where you need to stop. Suppose you have to bend. Suppose bending you are doing. There also you have to click.
Like this.
Yeah, if you click, it will stop there.
Okay, yeah, got it.
Okay, then again you click. Yeah. So somewhere you extra is there, you can delete that. Select and delete. Select and delete. 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 Yeah.
Okay. Yeah, got it. Thank you.
Okay. So anyhow, today I'll tell you from new one. So one, this is schematic is done. So those who are new people, for changing this is width and length, you can apply total width property. Q is the property. First you have to select, then Q. Press Q. This will become. Then you can select total width equal to 360. Then apply. Okay. You want to change length width. Suppose this is the way. Other at the time of the instant also you can do. Anyhow, this is the one for this. Q means it will become this one. Okay, so let me today we will discuss again from layout. Layout Excel. Create new for those who did already. Then layout existing. Don't change. This is I am doing from starting. It will just revise for those who people I am doing today. So this window will become. Now this is the blank window. If you press E, your dot is looks not. It is not looking good. You can press none, then apply. See the dot mark is removed. This is called grid mark. Anyhow, that is not required. Now once this is done, go to generate from source. Generate all from source. So where it is present, this is the corner it is present. Again I am repeating this point. So layout Excel it will become. So you can untick IO pin and peer boundary as of now. Then press OK. Your PMOS and NMOS will become. It will be in red mark. So to see this, you have to press Shift F. So if you press Shift F, your layer will be visible.
Sir.
Yeah.
I don't have that the bottom bar over there. Can you check on my computer? Yeah, the bottom side got this one, right?
Fit, if you press Fit.
Yes, pardon?
F for Fit.
F.
I think you deleted all. So you can undo. U for undo. Suppose you deleted by mistake.
Okay.
If you going to back that page, you can press U for undo. Okay, so you see EU again I have to delete. So Shift U, press Shift U.
Shift U.
Yeah, it is be like going forward, going back. Understand or not?
I can understand.
Yeah, you press means it will become back. Shift U means anyhow I'll write that command also.
So,
Sir,
Yeah.
can we draw the layout in any quadrant, or it's a first or second, or in any
It is in
specific
first quadrant. Try
Okay,
to make it first quadrant.
okay, it's only drawing first quadrant.
Yeah.
Okay, thank you.
So layout make first quadrant only. Even I am doing also. If you see, all my layout will be first quadrant. So these are the way I drawn. We are using. W. Suppose your launch layout, how to generate from schematic, go to launch. Hit launch, layout Excel. So Excel is the connectivity. What is the advance also there? So for time being, you just to know layout Excel.
Okay, sir.
So once this layout window came, generate all the source. Okay, so now you will able to see this layer. So this is the first current. So you can move this to first current. How will we move? For move, you have to select this, press M for move. Mouse left click, you will do like this, it will be moved. I think initially everybody will face this tool issue. So you have to practice more, then it will be easier. Your lab will be very easy. So this is the time being PMOS and NMOS. So already I told you in the PMOS, what you will be find which layer. So how which layer are present? I just revising it. In here today we will be complete inverter layout and DRC and LVS and DRC. So you have NOL, this is P plus, this is gate or poly. So gate and poly both having same. So P plus you will see in the layer P implant, and one term is called active layer. Active layer is the combination of source, drain and gate. So this much layer is the active layer. This is the active region. This is NOL, P implant, poly, and these are called base layer. So this is we need to connect, like you have to pass the current. So current who will be carry, that is conductor will be carry. So metal will be carry. So but this is a semiconductor. So connection between semiconductor, that is called one term is called contact. So contact is the connection between metal and semiconductor. The semiconductor and metal, it will not never short. So there is a connection required. So for that one contact is required. Connection between is the connection and contact where it will be there. So second, so contact will be there between. So in the layout you will find this. If you see, this is the green one is the poly. Will be go one layer. So this is the poly or gate. Now PMOS. PMOS means P implant will be there. P type of semiconductor. Okay. I told you oxide. One term is oxide. This is called active region. So this is a combination of source, drain, and gate. So this is source or drain. You can take either your. This is depends upon your wish. So there is not a specific to this one will take source. This one will be taken as well. Next, It is in PMOS, it should be inside N well. So this is the N well. Next term. So this is a semiconductor. So connection between oxide you can tell, and contact and metal one. So this is the connection between source to metal one, or either drain to metal one. So this white is a contact. Understanding or anybody having doubt? So you can tell contact is the connection between so this term is called diffusion. Anyhow, diffusion I'm giving oxide diffusion. So the term is not, or sometimes this is called oxide in the layout. Oxide contact, then metal one. Why metal one? That also metal one, metal two. So there will be, to avoid short is there. So you will next you will understand better. Then M1 and metal one. Or for poly to also get also need to connection. So how will we get connected? Poly contact then M1. So this is like interconnection between diffusion to metal one or poly to this poly semi. This is also semiconductor. This is also a semiconductor. Depends upon the N diffusion or P diffusion. But this is the connection between. So now if you see your layout, this is already there. So you are not doing manually. If you see, this is a, this blue mark is a metal. This white is a contact. This is a diffusion. So this is the connection between. This is source. This is the drain. And similar NMOS. So NMOS means you will see N implant, and it is no by default these are P substrate. Okay, so you have three terminal. Gate contact also you can take. How will we connect the gate contact? If you Q, go to parameter, you have to turn on gate connection. Gate connection, let assume bottom I press, apply. For PMOS I am doing bottom. So now gate contact automatically will become. So if you see, already I told gate poly contact M1.
Sorry?
Yeah, I can. You're asking anything?
Sir, can you explain an implant and the implant means?
Sorry, I cannot hear.
Sir, an implant and P implant.
Okay, so N implant, P implant.
Yes, sir. Yes.
So if you see in the layout, this is the P plus or N plus. Okay, the P type of semiconductor or N type of semiconductor. So this will be how in the layout it will be mentioned. So this is like they will put in the cover, like all the cover, but wherever it will be intersect with active region, that will be act as your source or drain. We can go to, okay, N implantation, this is a process. Let me discuss a little bit in the fabrication. So in the fabrications, so this is the CMOS. So you have N plus and P plus. So this N plus P plus, how it will be formed? So there is a process called ion implantation. So in this ion implantation, this N plus and P plus will be formed. So that term N implant means N ion implantation, P ion implant. So these are called ion. So plus charge means plus charge or negative charge will be there. So this is all together called ion implantation process. So how it will be formed? If you see, so first step they have done P substrate, then Si2 layer, then photoresist. It is a light resist because it is in high temperature. UV ray is done. So one to oppose your light, so they are doing photoresist one material. So this is NOL. So this much layer NOL it is creating. Next, after NOL, so first P substrate NOL, then this gate will be created. So this is how gate is created. Next step is the ion implantation. Ion implantation means they have to create N plus together and then P plus. Next process P plus. So how they will be created? This is how they are creating. See N plus, then again N plus. So this is act as a body. This is the N plus, and this process is called ion implantation. You're getting?
Yes, sir.
Yeah. This is the ion implantation process. They are doing P plus also. So they will add the P type of semiconductor, like boron they will implant. So I just show the video where they're implant like 3D printing. So it is not you are doing from here. They're adding one layer over it. So in layout, if you see, just imagine this is so this is the layer they added. You just overlap. So this much layer they added depends upon the technology. This may be vary. So in this technology, it is they are adding this much layer, and it is the active region. See, so this is your implant layer. If you see, implant layer should be overlap here oxide. So then will be that will be oxide means this is your active region. And this much layer only. This is one is source, another will be drain. You can take your this is drain, this is source. But implant should be there. Implant N implant means N type of semiconductor, just as you. For P implant means P type of semiconductor. Implantation is a process. That's where this term will come. See, sometime it will be some layout. It will be P type. It will be different naming. So different tool will be there. For this tool, it is like P implant. It is given. You're understanding?
Yes,
You got,
sir.
yeah, you got the
Yes,
idea?
I got. Yes, sir.
Now come to this is your P type of this is N type. Now how much you can press? Like this much distance or you need to add. So there to know that you need a DRC. DRC is a design rule check. So if you run Asura, go to run DRC, it will show you. So every time Asura run DRC, you have to run. Whether it is correct, how minimum we can place. The minimum every time you have to follow. So if you see, this is the DRC. So you will get some error. For time being, this laptop I didn't cover till now. So when you combine, one this is basic class is done. Not basic, like the backup class is done. So will be cover latch-up. So latch-up means it is tab. If you place the tab, it will be cover. Tab means body. So if you till now we didn't place the body, the latch-up will be clean. Next error, poly area it is asking, metal area it is asking. Poly to poly spacing it is 0.12. Suppose where it is asking, this is the arrow mark. You have to click arrow. It will show you in the minimize. It will show you here you poly to poly spacing. Suppose I will not. If you maintain 0, it will not ask you. So I will align this poly to poly. Okay. Then we can go for tab. Tab means CMOS. Which tab is required? If you see layout, this is your PMOS, P channel. This is your end tab, your body. So this is called tab already. So you need end tab. So how you will draw? Go to create multiple path. This is called MPP, multiple path. Then press F3. Create multiple path. Your new term will come. Your PMOS is there. Here end tab. You have to select end tab. This will come. Then mouse left click. Then enter. Where you need to stop, enter. First mouse left click, it will become like this. Okay. Then you have to align this is annual to annual. For aligning, you can use A. Where to here? This yellow mark, this is the yellow mark. Annual, annual. Otherwise, you will get some error. So first you have to align this annual. Okay. Anybody having doubt? Go to create. I am repeating multiple path. Then function F3. You have to MPP template. You have to select in tab. Okay. Same thing for P tab. F3. You have to select P tab. Then hide. Here mouse left click. You have to click. The people are not clicking. They are drawing. So they at that time it will not come. Then where you stop, enter. Now I just align how much minimum I can take. So for that I need to run DRC. I got lots of errors. So why it is? Because I made it overlapping. But you have latch-up error is not there. So I just make it below. Again I'll run. Okay. So now it is asking has to read that error. Poly to oxide spacing must be greater than equal to 0.1. So which one is the poly? This green one is the poly. And oxide is present here. So if you see, okay, I'll turn on. First to select do non-visible. Oxide will be seen. Then select poly. Click this. This is how. So here to here spacing it is should be 0.1. How to do? If you press A is the ruler. Okay, for ruler means K you have to use. So except this is almost all bind key will be in first letter. Few are different, so that time I'll use it. For go back or undo, you can use first letter undo. U. Okay. So till now, anybody having doubt? So I just maintain exactly 0.1. And at last you have to do AB. AB means all visible. Non-visible, all visible. AS means all select. If you click also, it will show you non-select. If you do minimum, that is a good layout engineer one. So I point to one. Okay, so I'll not find that error now. So once this is done, you need to do start connection. So how will we connect? First do, this is a metal, this is a metal. So it will be connected. So if you see the inverter schematic, okay, I'll do repeat again.
Sir?
Yeah.
I have a question. Why is the layer of the tap as that of the oxide layer?
Yeah, this oxide layer is the active layer region.
Okay, is it not for the dielectric?
No, that is different. This
Okay.
oxide is called active region. To identify active region, that is the oxide. Actually, this term is called oxide diffusion.
Oxide diffusion.
Diffusion.
Okay.
But yeah, it is mentioned is oxide. Some books like some layer technology you will find that is diffusion. They will not mention oxide also. OD layer. Okay, so here it is in this technology they are giving oxide layer. But this is like a active region. If you see in your DRC, whenever it is oxide is asking, it will show you the active region also. So don't confuse, this is a active region.
Sir, how can remove the roller?
Shift K.
Okay.
Yeah, anybody having doubt here, I will write this and I will send in the group. See, undo, redo. Suppose by mistake you deleted anything, you can use undo, U for undo. Redo means shift U. Okay, now it is removed. If I do undo, see ruler are there. To remove this ruler, shift K. Okay, now what I am doing? So connection. Connection means source, drain, body also connected. So as per schematic, you have to follow the convention of. So this is VSS connected, body is connected. So this is drain, this is source. So source is connected to VDD. So let's assume this one is source. So how to connect? This is a metal. This is also, if you see, this is a metal. So two are conductor on. So no need to add any extra layer. Just use path for your select metal. First you have to select. Then metal one will be come. Where you stop, put enter. So this is source is connected to VDD. Anyhow, for identification VDD, we have to add a pin that I will tell later. Next, so you have to this one connect. Suppose I need to connect this metal to metal. So what will happen? It will be ask you the error, the spacing error. Okay, anyhow, I'll run and I'll show you. To avoid this spacing error, so what we will do, you have to move this metal to little bit. This is the one option. Second option also there. So before that, you have to move, but it will ask you minimum width of the metal. See, this is minimum. If you see, this is 0.65. But okay, I'll run and you will not understand. Let us run with PRC, because last time one guy sent me. So this is we are doing drain to drain connect for output. So it is asking metal width should be 0.1. Where it is highlighting, just arrow. See, this is asking. So if you see measure, this width is only this much width. See how this is like a water pipe. Water is entering like this. It will be see this much distance. This is very small. So like this is the current also. For that reason only they are getting. So you have to stretch little bit down. So you have to measure 0.12 also. I think here it is fine. I can run. The minimum 0.12 you have to maintain. That error clean. Now metal area. So metal area, once this is all the routing, if you complete, then metal area you will not find. And see, this is how we are connecting. Drain is connected to VDD. Source is connected to VDD. Drain connected to out. Source is, so this is your NMOS. Source will be connected to DSS. This source will be connected to PSS. See, it is not properly aligned. So for aligning, you can use A or you can use move also. Depends upon your compatibility. You have to select. Okay, this see I have to align yellow mark where to here. Automatically see this align. So aligning it will be good command. Maybe it will be easy. Now one this is so once this is done, you can use this is also. This is for get connection. You can use a metal one. Now you will find a 0 DRC. So once this is DRC clean, you can add the pin. See, no DRC error found. DRC means design rule check error is 0. Now after DRC clean, add the pin. So as per your schematic, same pin you have to add. In my schematic, it is same pin name. So if it is capital, you have to add layout in the capital. So how to add a pin? Use Control P. So add pin. Control P. So you will find this window. Okay. And suppose you want to name this pin name, display terminal name, you can click. Suppose this height you can reduce to 0.2 or 0.1 also fine. And front page you can select Roman language, you can visible. And this is text by default, whatever is there. I'll repeat this point because some people. Control P, use Control P. This window will become, then tick my display terminal name. So you can see the terminal name. So you type BDD, so as for your name. Okay. Go to display terminal name. You have to select your Roman. Then height you can change to 0.1 or 0.2. So let I am doing 0.1 or 0.2 also you can do. Then OK, height, mouse left click, like how you are drawing a rectangle, like this you have to draw. But before that you have to select metal 1 pin. You can source also. So this is your metal 1 pin. First one, M1 pin. You can see this pin name is BDD. Getting? Then you can click use layer. Every time you have to click the M1 pin. Otherwise, if you select M metal, you will be here metal will be come. Are you getting or anybody having doubt? Let me know.
Yeah, I get it.
And then same pin, you can VSS. How you are drawing rectangular, same pin 3D. So this is your route. But be clear, this is you have to make sure that it should be in one pin. So this is the layout. Okay. So next we have to run LVS. So LVS means layout versus schematic. So what you will see, it will see your net are there or not, pin name as it is or not, device parameter. Device parameter means whatever length and width in the schematic, layout or not there, device mismatch. And net and reviewer, this is almost same. Reviewer means suppose this source is connected to VDD, CMOS source. But by default, you connected to BSS. So you have to rewire again, properly connected or not. So it will be checked. A net error means all nets should be present. So this is one net, this is one net, input net, output net, VDD net, and BSS net. these net are corrected or not, so it will be fine. So anyhow, I'll show you one error clean. Asura run LVS. See, this is your clean window, means your LVS is clean. Extraction and comparison. Everything is clean. Suppose I'll do a mistake. So first we will see pin error. So how to arrange? Okay. So this is I deleted. So this source is not connected to VSS. So I'll run LVS now. So you will find this is the error window. Press OK. You will find LVS debug error. There's some error you will find. So where LVS debug. Then click here. You will find this is VUR and net error. Okay. Suppose I need to see. So first you go to net error. Open to. You will find this window. So first, don't clean this VSS. Don't highlight. Go to this ABC error. So first you have to clean ABC, some C5 naming only. These are the one on net. So you have to click here, probe and zoom. This is the step, so I am telling. So if you zoom, so it is in the layout, it will be show you this one is where it is highlighted. It will be highlighted in that area. So by seeing this, you will identify whether these are not connected. You're getting how I go, means how I the step. LVS debug window, you have to click open tool. You have to select net first. If it is okay, the step one should be pin error first. Then go to net error. If pin error 00, so that's why I didn't check. Then go to net error. If you pin your net error clean, almost will be parameter is the last option. Device and parameter. So these are all are interconnected. So parameter means whether it is length and width is not up, that will be showing parameter. Device means suppose in the schematic 5 devices are there, 5 PMOS, but in layout you have 3 PMOS, 1 PMOS missing. So this is a device error or one device is not identifying. So here if it is missing, but this device is not connected. So it in layout it is not identifying. So this is telling in the one device. But in device error, if you highlight, it will be difficult to find to clean this error. So that's why step one pin, then net error.
Sir? Hello?
Yeah.
Sir, could you repeat the device error like number and
The device error means in layout. So this is the two device. One is PMOS, another is NMOS. Okay. So in this device, we have been connected this source to. It is like this. Means in the layout we didn't connect this source to here. So in layout, it is not identifying these devices properly. Means something source is missing. So it will be come under device error. But you don't need to clean device error first. Understanding?
Okay, sir. Yeah.
Yeah, you don't need to clean. It will be come under net error. So first you clean net error, automatically device error will be clean. You're getting? parameter error is different. Parameter error, suppose I will make it to, okay, let assume I will show you parameter error. Let I make in schematic 480. It means the length and width is the PMOS 480. In the layout, I'll run LES now. And always running the schematic, do check and save. If you don't check and save, it will be show you the error also. See here parameter error you got. You understood? Schematic, some length and width are there, but layout it will be different. So you will get parameter error. Okay, so this PMOS having rotated. So if you probe zoom, it will show you this device is having error. Or you can see this is the schematic part, this is the layout part. Understand parameter device error?
Yes, sir.
Yeah. Yeah.
Yeah, so anybody is facing DRC LVS issue, we can cover. Class will be complete at 1 p.m. So you have 10 minutes.
Sir, actually, I was checking through the library that to create, but I saw that the library was deleted by someone. I don't know. It was deleted.
You're 62 now.
Yeah, yeah, yeah. Yeah, so this Sumit is already, it has been deleted actually.
If you delete it, you can go to class file. There is nothing is showing.
Yeah.
Okay, you can just send to the, yeah, here it is. No, this is a different one. Okay, you can create. It will take very less time on file new. Already created.
Yeah, I have not created, but I will create that thing. But I was thinking that if that is any possibility to retrieve those deleted file, that's why.
And your inverter only, so that will take by drawing only. It will take the less time.
Okay, sir. Okay, I will do that. I will do that.
Okay.
Okay, I will do that. Okay.
There is an option there. I can check. Wants to retrieve. You can carry on. I think not possible now.
Okay. Okay.
Yeah. Any other having doubt? Any?
Yeah, hello, sir.
Yeah,
Hello.
Pratik.
Yeah, I created the NAND gate layout. I just want to know how to create that jumper from NMOS to PMOS. There is a one jumper, right?
Tell your number.
24.
Okay. So what do you want?
I want to connect this pin to here.
Okay.
Output
So
pin.
yeah. So for that you have to use a higher metal. So M2 pin. Okay. So I'm just doing it.
Okay, okay.
So it will be avoid short. So this is how you can do. But I will not suggest to here. I'll do here.
Okay.
You can use auto here. So for M1 to M2 connection, I told you the connection between metal to higher metal to metal. So you need a via. How will we
Okay,
connect? If you press O, auto option you select.
Mhm.
Okay. O for creating via. Hide. If you select, automatically that via will become. I'll just
Okay, got
repeat it. O for creating via. Select auto option. Then hide. Automatically you have to select. But it should be C M1 and M2.
Okay.
So via is the connection. I will add this point also. So via is the connection between metal 1 to metal 2. So via 1, suppose higher metal, suppose avoid any sort between M2, then you can use M3. So M1 to M2, you need via 1. So via 1, just a first term. Suppose M2 to M3, via 2. That will be by using create a via. So we can third of 13 point, create via. So that we have the command is O. Then select auto option. Yeah. So next, any other doubt? Anybody? Yeah. Anybody asking that time?
Hello, sir.
Yes, Sangeet.
Sir, can you repeat the LBS run?
You have tool access.
Yes, sir. So 76.
76.
Yes, sir.
This one you na. So you can
Yes.
go for Asura. Run always. You can press OK or apply also. You can OK continuously. Yeah, it is clean na. Any window came?
Okay.
कहाँ से हो आया
Okay. So you didn't launch the path, correct path. CD project in cadence works 76. Okay. So you attach like this only na. So library GPTK 90 you attach.
Mm.
Again here I will give the path 100. DSC is running fine now.
Yes, sir.
I think other can leave. Checkbox, uncheck it. Which one you are telling? Yeah, Pratik, can you tell which one?
So when you open the run LVS, the schematic design source, there is a checkbox, use Verilog top cell. Just uncheck that on the top of the form.
Okay, here you are telling.
Top of the form. On the top, scroll up. There is use Verilog top cell. No, uncheck both of those. Use existing netlist and use Verilog top cell.
Yeah, this one, correct.
Yeah.
Okay. Yeah, thank you. Actually, I didn't check that. Yeah, just compare it. Okay. Anyhow, now it is running. So you don't need to change anything. So this is already by default. DRC and LVS. This path are already by default. Okay, so don't need to click anything like parameter, everything. If you click, it will not run. So it is by default set for others, everyone. So no need to click anything here. So see, by default, this one she clicked. So it is for Verilog file. So we are not taking any. But this is for Verilog. This is for netlist for general PDF people will do. Any of these two are not required for now. Okay, so thank you all of you. So will be class. Yeah, Sangeeta, you can continue. It is working now.
So this video will be uploaded in YouTube later on, sir.
Yeah, it will be uploaded.
Okay, thank you.
Yeah, thank you all of you.